So the negative 30 comes down. And now the whole process starts all over again. So we have the first term divided by the first term. 10x over x is equal to 10. So here I put a plus 10. Next, we multiply 10 times this entire binomial. So I get 10x minus 30. Next, I need to change the signs and add. And you'll see this is going to go away like it always does. And in this case, this also goes away. So my remainder is 0. So the answer to this is just the quotient. This is the quotient. So the answer is just x plus 10. 0 remainder. Okay, this one here, I have this times x minus 1 to the power of minus 1. Now, power of minus 1 is the same as 1 over something. So what I have here is x squared minus 13x plus 12 times 1 over x minus 1. All right, so times 1 over is the same as divided by x minus 1. So this is going to be long division again. X minus 1 divided into x squared minus 13x plus 12. Okay, so it's really important for us, first and foremost, before you start, to make sure that your exponents are written in decreasing order. So here we have x to the power of 2, 1, 0. And if 2 is the highest exponent, all the exponents from that number to 0 are represented. So x to the power of 2, 1, 0. Okay, so let's get started. Same algorithm. First divided by the first. X squared over x is x. Now comes the multiplying. X squared minus x. Change the signs and add. X squared minus x squared will go away. So here I have negative 12x. And now the whole process starts over. You bring down the 12. And we have negative 12x over x. That gives you negative 12. Multiply the entire binomial by negative 12. So we get negative 12x plus 12. Change the signs. Add 0 remainder again. So the quotient is going to be x minus 12. Okay? All right. Here we have, again, two polynomials, but this time this is not a binomial. This is a trinomial. All right. So again, here we need to make sure all the exponents are represented. The highest one is 4. Then 3, 2, 1, 0. Perfect. So we can start. So the divisor goes in here. And here's the dividend. Okay. Again, first term divided by the first term gives you x squared. Now, we're going to multiply this entire thing by x squared. So we're going to get x to the 4, 3x squared, minus 4x squared. Change the signs. And add. Goes away. 4x squared plus 12x squared. I'm sorry, 4x cubed. This is a cubed. Sorry. 4x cubed plus 12x squared. Now I'm going to bring down a plus x. All right, so same stuff. First over the first. 4x cubed over x squared is 4x. So plus 4x. Multiply by the divisor. 4x cubed plus 12x squared minus 16x. Change the signs. minus minus plus, and add. This goes away, this goes away. Here I have 17x minus 12. Okay, now that the exponent here is less than the exponent of the divisor, we're done. So this is just going to be a remainder. So my answer will be x squared plus 4x, that's the quotient, plus the remainder over the divisor. Okay, so next. All right, so next we're going to talk about synthetic division. Synthetic division is a second way to divide polynomials. It's sort of like fake division. So let's talk about how we do this. The good part about it is it's very efficient. Instead of having to carry on the x's, the variables, you could just let go of the variables and just deal with the coefficients. Okay, so let's go with this first one. First, make sure all your exponents are there in decreasing order. So x to the power of 2, 1, 0. Okay, now, here, we put in just the coefficients. So here we have a coefficient of 1, 7, negative 30. Make sure you take the negative along. All right, on the outside of our little table that we made, so we have to make a half rectangle almost. You take this, set it equal to 0, and you get x equals 3. So here we put a 3. All right, now here's how synthetic division works. 1 comes down for free. Whatever makes it down here below the line has to be multiplied by this number. So you multiply by 3, here you get 3. Now here you need to add this way, you get a 10. Multiply by 3, you get 30. You add this way, you get 0. Now, when you get to this point, that last number is always going to be the remainder. So in this case, there is a remainder of 0. Okay, now here's how this works. Every time you do polynomial long division or polynomial division, the exponent of the dividend always gets decreased by 1. So if we started with an x squared, it's going to go down 1, so it's going to be x to the power of 1. And these are going to be the coefficients. So it's 1x to the power of 1 plus 10. So the answer here is x plus 10 and remainder 0. Now, if you can see, this problem is exactly the same one that we had done here, and we got x plus 10. So you see it's a much more efficient way of doing it. Okay, let's do one more here. So for long division, we're going to make, for synthetic division, we're going to make our chart like this. Now here, let's look at the exponents. b to the power of 4, 3. Okay, you're missing an exponent of 2, and then there is 1 and 0. Okay, so here, let's put in the coefficients. 6, negative 8. Now remember here, you were missing the b squared. In its place, you have to put a 0, then 12, then negative 14. So if you look, you have exponent of 4, 3, 2, 1, 0. It always has to check out like that. Okay. Outside, we're going to take b minus 2, set it equal to 0. b is equal to 2, so I put 2 here. Okay, now, process is the same. First number comes down for free, and this gets multiplied by 2, 12. You add 4. Multiply by 2. You add 8. Multiply by 2, 16. You add 28. Multiply by 2, 56. You add 42. Okay, so this is the remainder. So the reason why I do my arrows this way is The ones that are going like this, the diagonals are like multiplication, and then the vertical ones are pluses. So that's a way to remember. Okay, now, here I had b to the 4. Remember, it gets reduced by 1. So here I'm going to get b cubed, b squared, b to the 1, and so on. So my quotient will be 6b cubed plus 4b squared plus 8b plus 28 plus the remainder of 42 over the divisor b minus 2. Okay, so that was a simple case where this term, when we're doing synthetic division, has a coefficient of 1. Well, what if that coefficient is not 1? When the coefficient of the divisor is not 1, then what we have to do is we have to divide the divisor and the dividend by the coefficient. And then we have to use synthetic division as normal. So let's do this one. Okay. So, two things here. First, when you check the exponents, you have 4, 3 is missing, and then 2, 1, 0. Also, there is a 2 here in front. So I need to divide this whole thing by 2 and this whole thing by 2. Okay, so now you're saying, why are we dividing both by 2? Well, remember, this is something divided by something else. So suppose we had 6 divided by 16. Is it possible for me to just divide the numerator by 2 and not the denominator? Of course not. Whatever I do to the top, I have to do to the bottom. So that's why you have to divide both. Okay, so let's see. When we divide this by 2, we get 4x to the 4 minus 2x squared plus half an x plus 2 divided by x plus a half. Okay, now we're going to make our little table. All right, here I have 4. And remember, I need to put in a 0 for the x cubed that I'm missing. Negative 2, a half, and 2. Okay, let's see if the exponents are accounted for. X to the 4, 3, 2, 1, 0. Yes. Here, I put negative a half. Okay. 4 comes down for free. Multiply by negative half, negative 2. You add negative 2. You multiply by negative half, whoops, and you get positive 1. You add here, you get negative 1. Multiply by negative half, you get negative half. I'm sorry, you get positive half. You add, you get 1. Multiply, we're going to get negative a half. And now when I add these, 2 minus a half, that's 1 and a half, 3 over 2. And that's my remainder. So now, we started with x to the 4, now it's x cubed. So that's going to be 4x cubed minus 2x squared minus x plus 1 plus 3 over 2 divided by x plus a half. Okay, I can't leave this the way it is, so let's do some scratch work here. This is the same as 1 fraction divided by something else is the same as 3 over 2 times 1 over x plus a half. So that's really 3 over 2 times x plus a half. What I want is for you guys to be able to go from here to here in one step. And then that's equal to, when you distribute, 3 over 2x plus 1. So that's the remainder, and you see we can now substitute it here. So we get 4x cubed minus 2x squared minus x plus 1 plus this, 3 over 2x plus 1. And you can see that we got the same divisor as what we started with here. All right, so always in this form, not in this form. This will not be full credit. Okay, last one. We're going to divide everything by 3. And this one I'm actually going to do in one step. So let's see if we're missing any exponents. 3, 2, 1, 0. We're not. Okay. Let's put the coefficients. I'm going to divide by 3 and put them in here together. So 6 over 3, that's 2. Negative 17 over 3. 6 over 3, that's 2. And then 8 over 3. And here I get 4/3. Okay, so 2 comes down, and I get 8 over 3. Now when I add these, negative 17 plus 8, negative 9 over 3, negative 3. Multiply negative 8 over 3. So that's negative 12 over 3, my mistake, which is negative 4. I add and I get negative 2. Multiply negative 8 over 3, and look, that gives you a remainder of 0. So now I started with a c cubed, c squared, and so on. So my quotient is 2c squared minus 3c minus 2, no remainder. All right, so that's the homework for tomorrow.